So we're streaming with audio, and I did change my battery this time, so it should be good for about a week. I didn't change the battery, so that's why it kind of died halfway through. All right. So I'm going into the Canvas website, so I can find out from where to where. We'll start in the second exam. We'll start with arrays. So we start with this particular. Okay. Okay. You guys ready? Okay. Very good. Yes. Only for the first 10 minutes. Huh. Okay, that's kind of strange. I don't know exactly why, because it's just like. Can you still make out what I said? Okay, but it's choppy. Well, thank you. Yeah, I'll go ahead and see if I can find out why that is the case, because I use the same setup for the entire duration, so it's kind of odd that it would only be the first 10 minutes. So do you notice anything that I did that transitioned from it to not choppy? I didn't read anything. It could be a network connection issue. We are streaming, so that means if the network is choppy, it might drop frames. The drop frames won't show up because we are not moving a whole lot noticeable. Yeah. Okay. So we'll be starting with this particular scope for the second exam. And basically everything after the first exam is in scope. So that means top-down design is in scope. Pre and post, we did not have those questions in the first exam either. So okay, and it goes all the way to subroutines until we get to the last topic of the subroutines. So it will go all the way up to local variables by value or by reference. Is that okay? All right. In other words, it's basically all the topics after the first exam up to and including subroutines. But there won't be any mixing of subroutines and arrays. So I won't be mixing those two concepts in the same question. There will be recursion. Yep. Because we this one of the homework and we talked about it last week already about the solution of the to the next and final big chunk of module. Because if there are any questions, today is a good day to ask those questions. Yes. Info, because we do that because when you get back to that line, we have to know what else is to copy the return info to the line number. Okay, so have questions and decided not to ask. So I'm going to make the assumption that there are questions, okay, and we'll go ahead and do this one time. And it's taking longer to start than usual. So let's time. It's interrupted. Cancel. There we go. Okay. So we'll go with why we have return info style. Define sub. What is ABC? To so that's a really in kind of return the identification. Okay, so we have should probably get used to this concept of using main. So we'll use main, and hey, here we have a local variable n, and say n gets invoke ABC, and then we use 34 to specify. Oh, cannot do that. Yes, we can. So 34 to specify parameter x, and define sub. Okay. And then invoke main. Here we go. So this is a fairly simple program. It has no global variable. It has two subroutines. We'll go ahead and trace particular. Undo. New window for this. Look at the trace. First, look at the code. All right. This no comments. There's no condition to evaluate. So okay, nothing to mention. Variables. We do not say variable. By value visible. But it does.
So what is it technically?
It
Is it
not a local variable. If before, I would have just variable characteristics local variable. Okay, so we'll see. First line that is out of the definition of any sub. Number number may return work on line more.
but
If line is a conditional statement or the beginning of a value does not make sense, that may we'll use return info. In this case, we just say that when we are done with main, when main gets to line 8, we will continue execution at post, which basically means we're all done. So in this case, n is a variable. Allocate the left available column, which is one C in this case, and it comes to the natural value. This is what we do with local variables. They all start with a value that is unknown. Then we, sorry, go ahead. There was A weird noise outside. Okay. All right. So we continue execution. There's only one line that does anything useful, which is line 7 of main. Line 7 says, eventually, the last thing we want to do on line 7 is we want to change n. But I cannot perform that operation yet because I need to know what is the value of the right-hand side. The value of the right-hand side on line 7 depends solely on the invocation of ABC. So I cannot perform the assignment operation. I have to invoke ABC first. Okay? So that means the operation I'm performing right now on line 7 is to invoke ABC. When you invoke a subroutine, you always have to remember how you can get back to the invocation. But in this case, I cannot use the return line number, because if I use return line number, which is telling me which line I have to go back to, then I have to, neither is what I want. I can say I can return line 7, but if I do return to line 7, I'll be doing this all over again because I wouldn't know that I have the invocation done already. I can say I return to line 8, but that means I would have skipped the assignment operation and n would not be changed. So neither works as a return line number, and that's why we need return info. Okay? So when we use return info, then we can specify that we are going back to line 7. But by the time we get back to line 7, we would have the invocation, replaced by a single value. That is why we choose this way to represent that we need to go back to line 7. But when we get back to line 7, this question mark will now be an actual value. Then we can actually perform the assignment operation. So is that okay? That's the rationale of why we have two ways to represent where we're going back to and why they are different. Are we okay so far with that concept? Okay? All right. But since it's an invocation of ABC, and ABC has a by-value parameter x, so that means we have to set up x, which means we continue to allocate columns from the the leftmost available column is now allocated for the parameter x, which is passed by value. So from this perspective, it is kind of the same as n, that we allocate an additional column. The difference is the invocation itself is telling us what value x should start with. So x starts with 34 instead of a question mark. That is the main difference between a local variable, starts with an unknown value, versus a pass by value parameter, which starts with a value that is specified by the invoke itself. So does that answer your question? Okay. All right. So now what do? We have set up all the items, all the columns. So we continue execution in ABC. The only line that does anything that's particularly useful is line 3. When we execute line 3, do we have the expression x? Do we know the value of the expression x at this point? Yeah. Yes. X refers to column E, which has a value of 34. So when you look at the expression of just x by itself, it has a value of 34. So the return statement is returning a value of 34. So what do we do when we know what we're supposed to return? We look up the rightmost in use return info cell, copy and paste it. Okay, so we copy and paste it, change the question mark to the value that we are returning. Remember, we do not write x here. We write down the value of the expression, which is 34. And that's it. We do not change n. We do not change column C. We just change the question mark to the value that is being returned. Then we move on. We move on to line 4. Line 4 is the end of a subroutine. So that means it's time for me to figure out where I should go back to. So this is when we make use of the return info cell. Okay, we say, well, I need to figure out where I'm supposed to return to, and that's the job of the return info cell. So the return info cell is now copied and pasted to the line number column, like that. This way, when we do get back to line 7, we know how to continue on line 7, as opposed to, not really quite sure which part of line 7 is already done. We know exactly which part of line 7 is done. So that is the reason why we are copying the return info cell into the line number column. Okay? But we have another thing to do, because at this point, the invocation is done. Whenever an invocation of a subroutine is done, everything that you allocated earlier for that invocation should now be deallocated. And this is how we represent that this stuff is no longer in use. So we go to text, and we just do a strike through. And now we continue execution on line 7. But line 7 is no longer the line 7 that was in the source code of the pseudocode. It is now just like this. Well, we know what to do now, because the right-hand side is a particular value of 34. We want to change n to 34. So now we look up the rightmost in use column that is labeled n, which is column C, change that to 34, and then we move on to the line that is next to line 7, which is line 8. Is that okay? So as far as to answer answering your question, we are done, okay? But the program is not done yet, so I'll go ahead and finish it. But I just want to make sure that I addressed that question originally. Is that good? Okay. So when we get to line 8, we have to go back. So line 8 in this case is here, but since this is the end of a subroutine that does not return a value, we look up the rightmost in-use column that is labeled return line number, which is column B in this case. Column B says just go to quote unquote go to post. So we write down post here. Oops. Okay, I have to keep an eye on which window is active. So we write down post here, and then at line 8, okay, we also say that these two columns are no longer in use because we are done with the invocation. So now we mark these two columns as available again. Then we continue on the line called post, which means we are all done. So this is the end of the trace. Yep.
So the only difference between a local variable and a by-value parameter is that x just has a value given to it.
X starts with a value that is specified by the invoke statement. N is a local variable, so the code that is invoking has no idea of what its value should be. Not have a value until we get assignment operation, the subroutine itself to give it a value. Yep. On row, oh, that should be N. That should be N. Thank you. Huh? It's oh right because I copied, I did not copy, I just pasted, so that's why it's using the old content to paste. Yep, thank you. Anything else? So this program doesn't really do anything useful, demonstrating the concept. That's all it does. So are we good so far? All right, okay. Cool. So what we'll do now is we're going to mix a lot of concepts. So this is outside of the scope of the exam, of exam 2, but it will be in the scope of the final exam. So before I move on any further, let's make sure that questions related to the exam. Yes, go ahead. Mm-hmm.
So for the parameter passed by reference,
Mm-hmm.
so I know on the spreadsheet we could say aka column C.
Mm-hmm.
I do want us to do that on paper. Do I
On
tell
paper?
columns?
So on the paper, you will have to designate columns too. So that's a very good question. So when you're in exam 2 and there's something passed by reference, you will have to start to assign names to the columns. And I would just pick the same type of convention here. Just name the columns A, B, C, D from the left to the right. And when you have something that is, then you just then you can use exactly the same terminology of this to whichever column you want to refer to. Okay, very good. That's a good point. Yep.
If we have a nested subroutine inside another function, after execution, hang outside the subroutine. And where do we know where to go next? If we have a subroutine
So that question is a little bit ambiguous because are you talking about the definition of one subroutine inside the definition of another subroutine, or are you talking about having one subroutine to invoke another subroutine? We do not have. Okay, so once again, it's a terminology thing. We have one subroutine that is invoking another subroutine, but when you say having a subroutine nested within another subroutine, that usually refers to having the definition of a subroutine inside the definition of another subroutine, which we do not have because C does not support that. Some programming languages does allow you to define a subroutine inside the definition of another subroutine, but C and C++ does not allow that. So is your question about the definition, the nested definition? This is not considered nested. Hmm? We have two individual subroutines. Okay, one has a statement to invoke the other. That's about how I would describe it. Yep. Why did I? The post in column B. You mean here? Well, that's. I need to remember where I'm supposed to go back to. That's the whole purpose of the return line number. Line 9 is the last line already. I don't have the next line to go back to. So the only way to specify that quote unquote next line where I'm supposed to go back to is to say post. Mm, I don't understand what do you mean by when we are still doing stuff. When we get to post in the trace, we are done with that algorithm, right? Okay. But when you need to remember where to go back to when you're invoking a subroutine, and the invoke is on the last line of the program already, so instead of saying going back to line 10, which does not exist, we just say we return to post, which means when this subroutine is done, then the entire trace is done. I think you got your hand first. Almost the same time. Yep.
So when you say and define subroutine, what do you specify? On row 8,
Uh-huh.
define subroutine max.
You mean this one here?
Yeah.
Well, in that case, it is, you can look at define sub as the open parentheses, and you look at end define sub as the closed parentheses.
That's why I think it comes nested.
Well, nested means you have a construct inside another construct of exactly the same kind or similar. That means that becomes nested. Like a while inside a while loop, that's nested, right? But this is not nested because what is inside what is on is not a definition of ABC. It is an invocation of ABC, and as a result, it is not nested.
No, I mean specify if the specify.
Hmm? It specifies.
Yeah, can you define say that is it okay?
Say that one more time.
Like in row 8.
On row 8, on line 8. Uh-huh. You need to specify that because the only open define sub is main. So there's no need to specify main again. Because the only time you want to specify what name it is ending is when you can have multiple things end at the same time, then you have to choose one. But because in this case, the only thing that is open as a definition of a subroutine is main, so there's no need to name main. But if you say main, I'm not going to take any points off. But there's no need to do it. Okay, so go ahead.
Oh, I was gonna ask though, the traces on our exam, would it be comparable to the traces that we had from in frequency wise?
In terms of what it will test, what kind of knowledge it will test, whether you understand or not, yes, it will be comparable to the homework assignments, especially Fibonacci, which is recursive. But there will be, passing by value, passing by reference. So we don't have a homework assignment, that works on passing by reference. So, so that's one of the things that you have to kind of review, because I do have several programs in class to illustrate the passing by reference. Yep.
So Fibonacci is also scooped in the test, right?
Yes, it is definitely in the scope of the test. And yep. Yes, it's open notes. Any other questions? No other questions? All right. Well, if there are no other questions, I'll move on. So, no questions about recursion? We are all good? All right. Okay, if you guys can think of anything before the end of today's lecture, just let me know. We can go back to an earlier topic if we need to. Does anyone have any questions right now? Nope. Okay. So what we'll move on to, is kind of the last module that I have available. It has to do with types and records. So we'll go into the actual module and find out what is the idea of a record. Okay. So a record without a record, okay, it's kind of like, okay, you can read the examples, okay. But if you look at real life, okay, with the concept of a record, it's really just a collection of items that you put onto the same piece of paper, if you will, okay? So if you need to fill in an add form or drop form or something like that, it is a record, okay? Because what is on an add form or a drop form for ARC? Well, add, like, you need to turn in a form to add to the class. You don't know what is an add form? Okay, we'll pick a form, and we'll just add form college. Okay, any college would do. But I want a printed form, so we'll look for PDF. Okay, so this is not a bad one to look at. Okay, it's not about this college, but it has the same thing. So it has an ID number, right? This is one piece of information. It has the term, which includes the year and also the semester of that year. It includes name. So in this case, the name is separated into three parts: last name, first name, and middle initial. Is that okay? So all of these, each one is quote unquote an individual piece of information. But when you scroll down, it would have some additional information. So right here, it has, a table for add and a table for drop. Each row of the table of add has CRN, which is probably course number, subject. No, this is course number. This is probably the section. It's not the section number. It is, what is CRN? I think it's a unique ID for cross-reference number. Okay. This is section, so a particular course may have multiple sections. There's the title, grade option, if it is applicable, credit, instructor signature, and then also the date for the instructor to sign this one. Okay, so this is actually not a very bad example because it also has the concept of an array intermixed with the concept of record. But for now, we'll ignore this part. We'll just look at the first part of the form. Okay. Now you can also see from the PDF, this is actually, except for the instruction, everything fits onto one sheet of paper, double-sided. Is that okay? So now go ahead and imagine, instead of having one single sheet of paper, now we say, we'll give you, so fill in your ID on the little post-it, and I'm talking about post-it about this size, okay? Fill in the term on a different post-it about this size. Fill in your last name on another post-it about that size, your first name on a post-it about that size, your middle initial on a post-it about that size. So instead of having one single sheet of paper, now you have a little stack of little post-it. And on each post-it, you might even write down, this is my first name, this is my last name, this is my middle initial, this is the term, and this is my student ID. Is that okay? So you run into another person who has another stack of these little cards. I shouldn't have said post-it because post-it kind of stay together. So you think of these as individual small little pieces of paper about this size. Okay, so you run into the other person and then everything got dropped. Yes? A what? Index card. Okay, yeah. So anything that is not self-adhesive, that has an ability to stay together, right? Is that kind of what you're saying? Okay. So now what do? There's a whole bunch of tiny little cards on the ground, and it's harder to pick out, which one belongs to which person. Is that making any sense? Okay. So that's kind of what life is like without the concept of a record. The concept of a record is we put individual items into one collection of items. And we have already encountered a concept like this that we call an array. Remember arrays? So with an array, you can put several things into a box. But there's one big exception. The one big difference is everything in a box, in the case of an array, they all have to have the same type. So they can be all numbers, they can be all names, they can be all zip codes, but you cannot mix things up. Okay? Not in the case of C and C++. If you're talking about the scripting language, yeah, you can kind of mix things up in an array. But when you're talking about C and C++, you can mix things up. Is that okay? So that's the basic concept of an array from the perspective of a real-life example. Okay, a single sheet form with multiple items you have to fill in versus the tiny little pieces of index card that you have to fill in. One index card is only good for one piece of information. So in order to turn a form like this, you'll be submitting like a stack card. Okay. So what about in programming? What is it going to look like, in programming when we do not have a concept of a form? I don't know how many people have taken enough math classes to know what a complex number is, but yes? Oh, sorry? Yes, it has two components. One component is the real part, and the other one is the imaginary part. The imaginary part is the coefficient of the square root of -1. Okay, so but without even knowing, what is a complex number, okay, we'll just say that we have two complex numbers here. We have a_r and a_i are two components of the first complex number. The real part of A, the imaginary part of A, and then b_r, b_i belong to the other complex number, the real part of B and the imaginary part of B. We want to perform an addition, okay? We want to perform a complex add in this case, and then the result is in sum. So sum is passed by reference because I have to change something that belongs to somebody else. So, but it also has two individual pass by reference parameters in this case. One is only responsible for the real part of sum. The other one is responsible for the imaginary part of sum. So we have 6 individual parameters. Is that okay? Now, the operation we perform here is not really that important. If you have taken the class in complex numbers, you will see that, okay, yeah, this is how we add 2 complex numbers. But the point is, we have a lot of parameters because each piece of the first number, the second number, and the sum, each one is split into 2 different parameters. Are we doing okay so far with this example? Yes or no? We good? Okay. So with this example, we will also find out that there's a limitation or there's a problem with this approach. Even though it's doable, there's a problem. And the problem has to do with when you're passing, when you're invoking that particular subroutine, this is what it looks like. That's pretty long. Okay, because you have 6 parameters to specify. So there are 6 things that you have to specify when you're invoking. Just being long is not the only problem. The second problem of being this long is if you switch the order in x underscore r and x underscore I, nobody's going to notice. Okay, you can make a mistake and switch things around, and nobody's going to notice because to the program, it doesn't understand that x has 2 parts, y has 2 parts, sum has 2 parts. It only understands that there are 6 individual variables to deal with. So it's a problem because you can make a mistake, and it's hard to catch a mistake in this case. So what do we do? Well, the way we do it is we use the concept of a record to deal with this. But before we get to records, the next topic is to think about what a type is. C, C++, Java, they are all strongly typed languages, which means this discussion applies a lot to those languages. Some other languages, like JavaScript, which also includes Node.js, PHP, Python, those are called scripting languages, and they are not strongly typed, which means you can kind of mix and match things a little bit more flexibly compared to a strongly typed language. But since most of you are taking this class so that you can move on to cisp300, we'll just use the context of C and C++ in this class. So what exactly is a type in programming? So at the type of a value indicates what we can do with that value. I'm just going to highlight the sentence, which is really important. Okay, so this one little sentence really tells you what a type is from the perspective of a programming language. So I'll give you some examples of things that make sense, and then I'll start to introduce things that do not make sense. Okay. I'm going to switch to my text editor here, and I'll give you something that makes sense first. Okay, what is this? Okay, let me turn off the line number because it's kind of interfering with what I want to show. What is this? It's 14, and 14 is a number, is a numerical value, right? So there are certain things we can do with numerical values. Most notably, if you look up any type of calculator, right, what kind of operation do you think a $1 calculator should be able to do? And division, right? Okay, so that's a very reasonable expectation. Addition, subtraction, multiplication, and division. Okay, but I do have to point out that you can buy a scientific calculator for $1 at the Dollar Tree certain times of the year. So you can actually do sine, cosine, tangent, power, log, and stuff like that with a $1 calculator. Yep, but only certain times of the year, like right before school starts in September, or maybe even the end of October, the Dollar Tree sometimes would carry $1 scientific calculators. Yeah, you can even buy a cup of coffee, but you can buy a scientific calculator. Okay, so we know what 14 is, and what about 71? Same thing, right? It's just a number. So would this make sense that sometimes we want to calculate the sum of 2 things and both are numerical values? Yeah, it makes perfect sense that we would like to do calculations like this. So 14 plus 71 is 85, okay? So it makes sense. And then we talk about, we have talked about 2 types already. What about this? Okay, what is true? True is a Boolean value, which means it's either true or false, but it's a constant of true in this case. False is the other one, the other value in Boolean, right? So true can work with true false values. Conjunction and, disjunction or, negation not, right? So in this case, what is the result of true or false? True or false is true, okay? Because we looked at the definition of these operators like really early on, okay? So it makes sense. So I will now present you something that does not make sense. Okay, what about 14 and 71? Would that make sense to you? It would not make sense, because when you see the operator AND or conjunction, you are expecting both sides to be Boolean. Okay, both sides need to be either true or false values, cannot be numerical values. So this expression does not make sense. What that is telling you is AND as an operator is expecting one thing. So AND as an operator is expecting the left-hand side to be some kind of Boolean value, and also the right-hand side to be some kind of Boolean value. Is that okay? Boolean is a type. It's the name of a type. Okay? So I'll do something that is also kind of nonsensical. Does that make sense to you? Do you know the result of false minus true? No, because because it doesn't make sense to ask the question, what is the value of false minus true? Because what do you need to perform subtraction? Numerical values, right? Numbers of some kind. Okay? So this not working is telling you that the subtraction operator is expecting some kind of numerical value, okay? And the other side has to be a numerical value as well. Is that okay? So from this context, Boolean is a type, numerical value is a type, because it specifies what operation makes sense, can be done, and what operations do not make sense and cannot be done. Is that okay? Are we doing okay so far with this topic, defining what a type is? Are we good so far? Okay, so up to this point, our variables do not have types. When we declare a local variable, all we say is local n, right? N can contain any value. Or in the homework assignment, in the binary search homework assignment, we just say there's a variable called found. But we never have to say that found is a Boolean variable. We just say there's a variable found, and it just so happened to have to store a Boolean value. Okay? So from here on, now that we are aware of what the type is, now we have to specify the type of all parameters and also all local variables. Are we doing okay so far with this concept? Okay. Now, just to carry numerical values one step further, there are two kinds of numerical values when you move on to C and C++. Numerical values types. Okay, there are two. One is integer. Well, two main types. One is integer, and the other one is called a floating point number. Okay, which is a fancy name. You will see this name again in cisp300. And they hopefully will explain to you why it is called a floating point number. From your perspective, all you have to remember is an integer can only store integral values, which means it can store -15, +16. That's all kinds of numbers that are integers. Floating point numbers can store numbers like pi, 3.14, and a whole bunch of digits. Okay, it can also store integer values. So when you specify the type of something, a floating point number, it can basically store what we call real numbers in mathematics. Okay, so when you see floating point numbers in C and C++, think of real numbers in your math class. How many people know what a real number is versus what an integer is from your math classes? Come on, you guys need to raise your hand. Okay, there are a few. And a few people smiled, meaning that yeah, I know, but I don't want to raise my hand. Okay, but it's really important. Okay, if you do plan to move on to cisp300, understanding what an integer is versus what a real number is from the mathematical perspective is important. Okay, I'm not going to talk too much about these two, so we'll just go ahead and say numbers are numbers in this class. Are we okay with that concept? Yes? Okay. But we do have one kind of nagging question. Isn't the set of all integers a subset of all the set of all the real numbers? For those of you who have taken classes like that? Sorry? It is true. Okay, so it is true that the set of all integers is a subset of the set of all the real numbers. So that means if we just use real numbers, then we don't need to know about integers, right? Theoretically speaking, because every single integer is also a real number. So why do we have both of these types? Say that one more time. Yes, but that means we don't need integers, because if we just have real numbers, that covers for the integers as well. So the question is, if we have real numbers, why do we need integers as a type, right? No, an imaginary number is basically just one of the two, because the two components of a complex number, they're both just scalars. In other words, they both are just real numbers. So we can potentially live with only real numbers. So now the question is, why in programming we also have a type of integer? It makes it easier. Okay, very good. So integers is what makes, how should I put it? The mechanism that you need to process integers, add, subtract, divide, multiply, and to store is a whole lot simpler compared to the mechanism to process real numbers. Okay, now why would that be an issue? I got two examples, one on each hand. Fitbits, okay, or fitness trackers and stuff like that, okay? Because any circuitry that can deal with real numbers in hardware is going to consume more power. So that means if you want your Fitbit or your fitness tracker to be able to last a week or even longer, you probably don't want to handle real numbers, because the circuitry to deal with real numbers is a lot more complex than the circuitry to deal with integers. So that is the main reason why we still have an integer type in programming, when in theory, real numbers really include all the integers as well. So it's a topic that I cannot really get too deep into in this particular class. In CISP 360, you will get into that topic a little bit. It is only until you get to CISP 310, then we'll look into the actual mechanism of how do we add and subtract and multiply and divide integers, as opposed to floating point numbers, which are far more complex when it comes to how those operations can be done. Okay, so it's a future topic for some of you. If you're not in computer science track, you won't have to take CISP 310, which means you don't really actually get to understand why these two types are actually very important in terms of the difference. Even though in theory, if you ask a mathematician, if you ask a math professor and say, well, if I can only have one of these two types, which one should I choose? A mathematician will say real numbers every single time. But the computer science person will say, well, it depends on what you're doing. Okay? So we'll just leave that topic as that. Okay, so in this class, we'll just say numerical value, and that covers both. All right, so that's basically the basic idea of types. So we got integers, we got booleans, and this one we don't really use a lot in this class. It's called a string. Okay, a string is basically text information in the store, because an integer or real number can store numerical values, which is useful, right? When you look at a Boolean type, it's true or false, which is also very useful. But when you look at a form, okay, you hardly have any form that only has numbers, because your name is not a number unless you're Borg. Okay, nobody's getting this one. Another Star Trek reference, right? So unless you're Borg, your name is not a number. If you're in the concentration camp, you get reduced to a number because people don't want to know your name. So since we're not, okay, we all have names. And what does your name contain? When you write your name, it has letters, right? So your name belongs to a type of what we call string, but we are not going to get into strings in this class, okay? So strings would be a concept that you would get into in the next class in cisp360. So in this class, we just focus on numbers and Boolean types. Are we still doing okay so far with types? And by the way, if you have strings, text information, what kind of operation do you think you might want to do with strings?
Addition.
Addition? Why would you say addition?
Or would I say addition? Because like what you be adding together.
You mean like this? If you have one string is tag, the other string is aoyang, you want to combine the two strings to become tag aoyang, right? This is technically called concatenation. Okay, it's concatenation. Basically you're copying both strings, the first part from the first string, second part from the second string, and you're making a longer string out of those two. It is technically called a concatenation operator in strings. Okay, so that's definitely something that we might want to do. What else do you think you might want to do with strings? Multiplication. And what would be the result of the multiplication of two strings?
I think that's
Okay, so let me ask you this question. If I have one string being AB and another string being CD, what is the result of the multiplication of these two? No? Huh? But AB is really just a name. Okay, let me give you a name instead, okay? So we'll say John, and we'll pick something that's, I want to be politically correct, so I want to choose names in a careful way, okay? Well, tag is fine. We'll just say tag. Okay, so what is the join times tag? No, that would be concatenation. We already talked about concatenation. Multiplication, huh? The space in between. That's concatenation. Joining is concatenation. There's no multiplication operator in strings. That is the whole point. It doesn't make sense, okay? And subtraction also does not make sense in strings. You cannot subtract a string from another string, okay? But, yeah, go ahead.
Could you like take a concatenated string to subtract apart from it?
So, okay, so if you are thinking about this, okay, so let me illustrate it, okay? So let me say, John Wong, okay, minus, John, okay? So most people think, oh, I should get Wong, right? Sort of, right? This is not called subtraction, it is called substitution, okay? Okay, so we are not going to get into this too much because string substitution is not a native operator in C or C++, but if you want to do this in a text editor, it is known as this, okay? So you're substituting John Wong with just Wong. Okay, so you're getting rid of the John part. Okay, that's a substitution operation. You're finding a substring and removing the substring. Okay, but we don't actually have a subtraction operator. You have to find the substring and then find out where it is, and then you have to specify we want to get rid of that. But I think we're all forgetting one thing that is actually making sense. Okay, comparison. Don't you think we compare strings all the time? Every time you look up a dictionary, okay, fine, you guys don't look dictionaries anymore, do you? How many people have a paper-based dictionary in your backpack? I am impressed. Okay, very good. Because these days you can just install an app on your phone if you think that you might lose internet connection. But if you think you're always connected, you just say, hello Google, look up blah, blah, blah. And I'm pretty sure many phones are active right now looking up something, right? Looking up blah, blah, blah right now. So that's why, we don't really appreciate the concept of string comparison anymore. But why do you want to do string comparison in a computer? Remember, we are not looking at things from the user's perspective because all of you are here because we want to write programs. So from a programmatic perspective, why do we need to compare strings? So that we can use it in a condition, yes. And what do we use conditions for? This is a topic that we have just recently, decision making, yep, and what kind of algorithm requires comparison to make decisions. We have just encountered, we have just talked about an algorithm not too long ago. Yes? Passwords, okay, passwords require comparison. So in the case of passwords, we are looking for equal, right? So we are looking at two passwords. One is stored in the database and the other one is what is entered, and we want to see if they are the same. Okay, so that makes sense. But we have just recently visited one algorithm that makes use of comparison, and it does make a lot of sense to compare strings. Yes? Sorting and searching. Okay, very good. So searching and sorting are the ones that we need to compare strings, because a lot of times we want to organize information by alphabetical order. Does that make any sense? Okay, so when you store something in a computer, so if you need to store the address of multiple people and you want to retrieve the address of those people, you need to sort, those entries either by first name or by last name, right? And then knowing the order, and but we're not going to work with strings too much in this class, but it is an important topic if you want to get to program. All right, so we're moving on to section 4. So section 4 talks about the notation of types. In other words, in code, we indicate the type of something. It's actually pretty easy. We keep the same syntax as we have, and then when we indicate the type of that thing, we just use one, and then name the type of particular. That's say that n parameter needs to be type. Also, this condition of compare that with other integers. On one or the multiplication, in a sense, to specify the type of the return value of a. Yes, no. So now we say, but what about that? This is binary search. So this is binary search that we have seen before, except routine. So okay, this I have to change by reference from by value to reference. When I wrote this note, algorithm code, I want cisp300 value. Boolean. Do you think the research of right? If it's found, we return true. If it is not found, we return false. We have local variables, b, e, and m. Why are those integers? Well, if you try to look at how we get values into b, e, and m, what is 0? What is the type of the constant 0? It's an integer. What about bar a bar? It's an integer minus an integer is still an integer. So b and e are definitely, they need to be integers. What about m? Now this part looks kind of, and it looks kind of funny, right? Because I do not specify the floor. So if I don't specify the floor, and m is an integer, C and C++ will automatically apply the floor operation. If you try to store like 2.4 into an integer, C and C++ will automatically store 2. Okay? If you try to store 6.7 into an integer type, it will automatically store 6 into the variable type, into the variable. So that conversion is automatic, and we don't need the floor operation anymore.
So if you need the ceiling, you have to specify.
Yes. So if you want the ceiling, you will have to specify it. The default operation is not exactly floor. It is what we call truncation. Because the one difference between truncation and floor is with when you have negative values. Because negative 2.3 has a floor of negative 3, but it has a truncated value of negative 2. So little things, but we are not too concerned about those in this class. Because our main focus is a record type. So what a record type is it allows you to define your own type. So C and C++ comes with their what we call internal types or built-in types or default types. So those with the booleans, the strings and stuff like that. But you can define your own type. Okay? In most programming languages, you can define your own type. In this case, we're defining complex as a type, and complex has 2 members. The first member has a name of I, the second member has a name of R, and this is how we define a record. Is that okay? So what exactly is a record? When you look at the record definition, this is the record definition. It is kind of like a template form. Okay, let me switch back to the template of a form that we saw earlier. This is the template of a form. It is a template because it is not filled in. It cannot be filled in either, okay? So this is a template. When you go into any type of office, okay, and you ask the administrative assistant and say, I need you to make more copies of a particular form, the one form that that person will put onto a copier is quote unquote the template. That form is never supposed to be filled in. So, can you what? Yes, on a physical form, but not when you're programming. Yep. So this is a template. Okay. If somebody says, "Oh, I need to add to a certain class, I need an add form," and you're running out of add form, so what you do is you take this template out, you go to a copier, right? Make a photocopy of the template. Now the copy can now be handed to a student and say, "Okay, now you need to fill in this form." You will never hand out the template itself to a student to fill in. Is that making sense? Okay. So getting back to our current discussion here. So when you look at listing 5, this is the template. All it is saying is anything that is of the type complex has 2 parts. The first part has a name of I, it has the number. The second part is R, it is also has the number. Is that okay? So how do we make use of a record type? How do we make use of a template? This is how we apply the concept. This is the same subroutine of complex add. Don't you think this one is a little bit shorter compared to the other one? Yes? Not looking at the content, not looking at what each line is, this is a lot shorter. But what changed? What got changed? There's only one A here. There's no A underscore I or A underscore. There's only one parameter A. There's only one parameter sum. And why can we do this now? Because A is not an integer. It is not a Boolean. What is the type of A? I mean, you guys can all see that now. What is the type of A? It's complex, okay? So that means when I look at this and say, oh, A is complex, the one thing I know now is it has got two parts. One part is called I, one part is called R. Okay, I and R are the two parts of a complex. E is the same way, sum is the same way. Sometimes you need the thing, other times you need to break it apart. So when we need to perform the actual addition, then we need to go to, oh, okay, addition itself is not defined for the complex type. So the only thing you can add are two integers or two numbers. That's okay. We can get to member R of A using this notation, using the dot notation. Okay, so A dot R is basically saying member R of A. Is that okay? Member, member, member. It is a part of A. Well, I guess in this case I chose a very poor name for a variable, right? Okay, so I'm going to write it down on this side. Okay, so we'll choose B dot R. Okay, that makes it easier. Means member R of B. Is that okay? Which also means the dot notation is kind of apostrophe S in English. Okay, so it means the same thing. B dot R means B apostrophe S R. Yep.
Kind of the same when you take something out of an array.
That's a good question. So the question is it kind of similar to the indexing operator, right? The square bracket. So in a way it is, but in major ways it is also no. Okay. So in a way it is the dot notation. In a way reminds you of the square bracket notation because it allows you to access a part of something that is a collection of something else. But the difference is with arrays, when you use the square bracket notation, it has to be a numerical value inside the square bracket, right? In this case, whatever is to the right-hand side of the dot has to be the name of the member according to the record definition. So that's the main difference. Yes, go ahead. I wouldn't call that a subset. It is just accessing a part of something that is a composite of other things. Hmm? Yes. So if you think about it in terms of a living thing, okay? Okay, so we can define okay, let's go ahead and define a car, okay? So we say record car, and now we can name the components of a car, okay? So you can have E, which is of the type engine, okay? You can have 4 wheels, right? So the wheels is going to be an array of 4 actual wheel types, okay? Do we have a chassis, okay, of the type chassis C? We can just use C here, which is of the type chassis, and so on. Chassis, I think that's how it's spelled. Okay. So this is how we can define a composite type, which is a car. It has a member called E. Called E. Okay, but the wheel itself is 4 wheels, and then we have a chassis. C is the name of the chassis, and the chassis spelled with the uppercase C. Yep, go ahead. Oh, I thought you had a question. So you might have noticed that now we use mostly lowercase stuff for variables, and then suddenly we now start to use uppercase. So have you noticed the uppercase? It is referring to a type. Car, engine is a type. Wheel is also a type. So when you break it up into multiple parts. So you will end up with a crankshaft. You will end up with all the constituency, the constituent in an engine. So you can keep breaking things down until everything breaks down to either an integer, a boolean, or a string. Question?
Yes. Strings always come in calculator.
Strings?
Yeah.
So when you describe a type by convention, we name types as with an uppercase, except for the built-in types in C and C++. So integer is int with a lowercase I. So when you get to a C and C++ class, you will know the kind of weird convention that we follow. But in this class, we'll just say that everything that is uppercase is a type. Are we still doing okay so far with the concept of types? Okay. All right. So this is listing 6 is only describing the definition of complex add. So when you look at this and you compare to the first version of complex add, you will see that the first one is a lot longer. Okay. Okay, let me see here. This is the record. And when you scroll down to where we are now, this is the current version of complex add. Okay, so it's a lot simpler. When you look at how we use complex, this is how we use it. So what we need to do now, have as complex. Sum is also complex, but you need to initialize x or y. Break it apart. Not assign value. No, if you just say which x is getting, are you talking about the part or are you talking about the real part? So that's why you cannot just say x gets a particular value. But knowing that by the complex record type, we also got components. One component is called R, is a number. Another component is called I, which is also a number. So when you look at those two components, the R and the I components, then each one can get initialized by a particular value. Is that making any sense? So sometimes we want to treat a variable of a complex or of a record type as a whole. Other times we have to access individual parts of something like that. Is that okay? All right. So when you look at line 19, that's how the invocation has changed. See how the invocation is a lot shorter? It was up here last time when we invoked complex add, because we have to pass 6 different parameters. Now it is shrunk to only this much. There are only 3 parameters. X is used to specify A, Y is used to specify B, and sum is used to specify sum. Are those types matched? Am I passing a complex to a complex? What do you think? Okay, so here we can see both the definition and how we use the subroutine complex add. Am I mixing and matching the types incorrectly? So you look up this one here, okay? X is of complex type, and I pass it to A, which is also of complex type. Y is a complex type. I use it to pass to B, which is also of complex type. And sum in this context is a complex. I use it to specify sum, which is also of the type complex in complex add. So it is okay. The types matched up correctly. We're still doing okay so far with the concept of a record type. Yes. Okay. All right. So let me check the time. Oh, it is time to go. So please read ahead of me before the next class, because we're going to work on records a lot more after this point.